Okay, two more things on slide 24 with the expenditure for product in the linear expenditure system. So the first thing is called the marginal expenditure propensity. No S over here, propensity. What is that? It's just simply the derivative of this expenditure, for example, P1, X1, the whole expenditure with respect to income. So how your expenditure on each good changes when your income changes. That's the term. So in this case, let's take P1, X1 as example. So we have P1 times X1 with respect to I will be. Now let's look at this and see where the income is. So it's only one place where income involved, and that would be something like B1 times I, right? The whole term, but only I over there. So your derivative is actually simple. B1. So it's a constant. Second point is the income expansion path, which we have seen before for the Douglas case. So now, how is it different from before? So again, from the first order, income expansion path is something we could derive on the way after the first order condition is derived. We at one point combining the first and the second equation in the first order condition, we got P1 times P2 times X2 equals B2 over B1 times P1, then times X1 minus C1 and plus B2 times C2. This is the equation for the income expansion path. We will take the slope of income expansion path, which is, in this case, let's write it here. You have, where do you have X1? Because the slope is dx2 over dx1, right? So here actually we have to write it a bit further, which is x2 equals, so there's b1, sorry, one missing. So b2 over b1 times P1 over P2, dividing both sides by P2. Then times X1 minus C1 plus P2 divided by P2, gone, right? C2. Yeah. And then this income expansion path. So this is actually the equation for the line, not the one above, sorry. So the income, the slope of this line would be where is it? X1 is over here. So let's write it down. So the only term in this linear equation you have x1 is p2 over p1 times p1 over p2 times x1. And the derivative of this term with respect to x1 should be b1 over, sorry, b2 over b1 times p1 over p2. That's it. So again, the slope is constant here when all the parameters stay constant. That's the first thing. That means the income expansion path is linear. Now, however, different from the case of the Cobb-Douglas utility function before, now in the equation of the income expansion path, you have this C2, a constant state standing alone. So that means there's like intercept. So income expansion path is linear, but not through the origin, right? Because intercepts different from zero. We made it. Now only a few points left for the linear expenditure system that we should keep in mind. Okay, so like I mentioned, C1 and C2 can be interpreted as the minimum consumption quantity, the minimum quantities of good that you have to consume, for example, in order to survive. Like we could think about the minimum amount of food that we have to eat to survive before anything else could be considered. So sometimes it's called the commitment. Okay, so now if we expand our problem to many goods case, many, not more than two. Okay, don't panic. It actually has a general form of the Marshallian demand function at the end, which always constitutes two parts. Now, so the first part is the CI, the committed quantity. And then the second part is the non-committed. So you're free to decide how much more you spend on each good according to your preference to maximize your utility. So that's the second part. Look at the term in the bracket of the second part. So here we have committed part of the expenditure, which is always the price of the goods, every goods times the committed quantity. So this is the expenditure that you have to spend anyway. Let's think about like the rent that you spend to your landlord every month. It's something like that. No? And then when you take income, your all income minus all of these compulsory or committed items, the expenditure of them, you have some non-committed income, some money you're free to spend to maximize your utility. And outside of the bracket is BI over PI which was similar for the case of two goods and also similar for the Cobb-Douglas case before. So nothing changed dramatically over here. Okay, I just said that already. So these, when you presumably the minimum consumption quantity is predetermined, then the non-committed demand will depend on, first of all, the income change, and second of all, the price changes, not only of good items, but also other goods. So these are the factors that will affect the non-committed demand at the end. And with this functional form, you could expand your system or your model to many, many goods, which is great. Nah?